Which one do you want to start with, kids? Which one? 19? 18? What, you did 18 okay? How about 18 and 19? We're going to have to do it anyway. So on 18, can someone explain to me what's your process for doing 18? What's your process? What do you have to do? What are you going to try to do first? Find the inverse by... Yeah. That's not what I know, and I have a pony at home too. I do, you're right. You're absolutely right. That's true. If you do try to find the inverse, what happens now? Well, the tan situation is not the problem, actually. It's the combination of the tan situation with something else. You're trying to isolate, what are you trying to isolate at this point? Yeah, you try to isolate y. If you try to isolate y, what happens?
Like the square root of the tangent.
How many y's do you see? Where are they?
Y squared.
That's what they are, but where are they? In two separate terms. And it's you've solved things with them in separate terms before. What's particularly problematic here? One of them's in a tangent, a trig function, and one of them is... Who cares if it's squared? One of them's inside a trig function, and one of them is not. Yeah. Simply put, can you solve things like this? Can you solve that?
No.
I don't know if you... No, there is. I understand that, but you, meaning pre-calculus students, do you have the ability to solve that?
No.
Not really. You have a problem when it's inside and outside. So if you try to isolate y here, you run into a problem. You can't. Now, though, what did you say before? Do you have to find the inverse to find the value of an inverse at one specific value? No, you do not. You absolutely do not. You know that f inverse of 3 equals some number, right? That's the same thing as f of what number equals 3. So you have 3 plus x squared plus tan pi x divided by 2 equals 3, and then you just solve this. Now you cruise along. Oh, the first step's nice. So you end up with x squared plus tangent pi x divided by 2 equals... you want to solve that problem being... What's the problem? Inside and outside. You have a problem there. Inside-outside trig function. Not cool. So what are you going to have to use? What? Nope, not common. Well, yes, you can use common sense, but you need to prove that it's the only one. That's correct. What are you going to use? Graph. Positive one. And we're trying to find out where it crosses the... to where it equals 0, so where it crosses the... x-axis. It happens to cross at the origin. We're trying to find out where it crosses the x-axis. Which function on your calculator do you use? If we graph y equals 0, we could use intersect, but we're not graphing that. Look at the options up there. What's one of the options? 0. So left bound, you go to the left of where you think it is. You go to the right of where it is, and then you guess. Oh, look, it is 0. Now, the thing is, yes, you can use logic. Nate, you brought that up. That's totally fine. I'd like you to also do this because in the next option, it's not going to be exact. It's not going to always be. And then you could use this to get an idea, and then, yeah, plug in 0. Does it work? Yeah, 0 plus tangent of 0 is 0. So in this case, x does equal 0. So now it's at... So what's the answer to this question? This equals 0. Is that correct? Okay, so if we want to solve the next one, if we want to solve f of f inverse of 5, do we actually have to do any math? Not especially. Because, why? You can think of it as canceling. They undo each other. So what's it actually equal? That's the short answer, and that's totally logicked out. You're undoing the function. If f takes r to s, f inverse takes s back to r. So from 5 to whatever 5 goes to, do you even care what f inverse of 5 is? No, you don't. Let's verify this, though. Let's verify it a little bit. We would need to actually find out what is f inverse of 5. Well, we want to know when does it equal 5? Well, if we go back and change this graph, remember, what do we need to add in here? Yeah, that was really important. That messed us up in the first class. And what do we put down here? 5. So there's the graph, and then you find out what... True, but I want to visually show you this right here. So what can you do now? Second, calc, intersect, first curve, second curve, and then it asks you for a guess. As long as you're in the general direction, it does okay. There's your intersection. Now, you notice how it says x equals? What has it saved that value as? It saved it as x. If I go back to my calculator and I type just x here and press enter, look what it comes out to. That's useful. You generally tend not to see that because every time you do one of these functions, it saves the value as. So every time you do it, what happens to the last value? It gets overwritten. You just have to be careful. So now, let's actually test what is f of 0.642. And how can we do that easily on the calculator? y1 of x. And it comes out to be 5. Is that exactly? On your calculator, you hit vars, yvars function. If you have an 84 or above, you can use that submenu thing, but it has to be an 84 or above. But yes, it comes out. We just checked it. That's pretty cool. Works pretty well. I like that. Okay, the second one says, yeah, go ahead.
There's multiple places. We're just trying to find one.
There's multiple intersections, but you're only going from -1 to 1. Yes. How many intersections are there actually? There's an infinite number. If it intersects once, it's yeah. I mean, I can think of times when the trig functions can get bigger, like x squared sine x. It oscillates, but it gets really big, small, big. Just be careful. On the next one though, next one's pretty straightforward. What are you actually trying to answer? You're trying to answer if you're trying to find g inverse of 4 equals something. So what are you trying to solve for? G of something equals 4. So 3 plus x plus e to the x equals 4. So when does x plus e to the x equal 4? Now here's the thing. Logically, you can find an answer pretty quickly. Logically, oh actually, not 4. What is it? 1. Logically, you can find an answer pretty quickly. But if you wanted to actually have a algebraic method, is this easy or hard to do algebraically? Really hard. Really, really, really hard.
Okay.
So how do you do it on your calculator? You graph it. You graph the left side, and you graph the...
Or the 1.
Yeah, or the 1, right? So what do you have? X plus second e to the... What is e? E is a... It's a number, just like... What's a number that it's similar to? Pi. It's an irrational number. We'll study it next. 2.718 goes on forever with no repetition. Like this. And then what should we do for the other function? 1. We graph this thing. Well, there's your exponent right there, x plus e to the x, and then there's your intersection. So if you want to zoom in, you could zoom in, but where do you think that intersection occurs? It does. It is the y-intercept, so it intersects at x equals what? Okay, think before you start mumbling numbers, everybody. There's this 1-ish 0 over there. Yeah, this point right here, if you run it, is 0, 1. So it's asking for the x-coordinate, so when it's x equals 0. Now go back to your original equation right here. Plug in 0 for x. You get 0 plus e to the 0. Well, that's 0 plus 1, which is 1. So for this one, what is this equal to? What is g inverse of 4 equal to? 0. G inverse of 4 is equal to 0 because g of 0 is... Yes. Very good. Very, very good. Is this exciting stuff? Is it? No? It's pretty good. Okay. Let's talk about 20. Someone mumbled about it. The graph of f is given. Why is f 1 to 1? Can someone raise their hand and very completely and accurately tell me why f is 1 to 1? Yes?
So for all the function, or all the inputs that go on the graph of f, there's only one singular output.
Correct. Can someone shuffle that down to even less words? Yeah.
It's always decreasing?
It is always decreasing. You're done. That's it. Visually, though, but what you said is absolutely correct. Visually speaking, we can only be as sure as what our eyes tell us, and it looks like this thing is always decreasing. Except possibly at 0, 0. Yes. It can have how many points not increasing or decreasing? 1. If it had more than that, you'd have an... you could have more than 1. You could have an... Wow. Because look, it could go like this. No, look, it could do this. I just thought about something. As long as the points aren't next to each other, right? Because you could do this. It could go down. It could go down. Right? Is that 1 to 1? Yeah, it could not be moving there and there. Right? So it's not just one. They just can't be next to each other. They can't be adjacent. Okay, so on this one, state the domain and range of f inverse. Can someone tell me what the domain and range of f inverse are? How do you find out the domain and range of f inverse? What should you find first, yeah?
The domain and range of f.
Yeah, so let me clip this in and then you can tell me. It's going to vary just a little bit. It's just going to vary a little bit. On this function right here, What is the domain of this function, right? Someone tell me what the domain is. Yeah.
Such that x is between negative 3 to 3.
Yeah, so you could say negative 3, 2, 3. And what's the range? Negative 2, 2, 2. So therefore, if you graphed f inverse, which they don't ask you to do, but you could, it gets a little complicated. You just have to be careful about this.
So that actually reflects across both axes.
Yes. Yeah. Well, it flips. Actually, you know what? That's a really poor job. That's not it, is it? You have to. Not at all, Mr. Seaman. Not at all. What's it going to look like? It's actually going to look like that, right? It goes whoop whoop, and then it goes right.
Exactly.
Shut up. The only problem is the points are off here. You know what the best thing to do is? Take specific points. We know it anchors at 0, 0, right? And if it's at 3, negative 2, it has to be at negative 2, 3, right? And if it's at negative 3, 2, it has to be at 2, negative 3, like this. Do you understand why those 2 points are there? What is the coordinate for that point? This endpoint right there. 3, negative 2. So if you mirror that across, what's it going to become?
Yeah.
Negative 2, 3, right?
That's what I meant.
Got it. Negative 3, 2 becomes 2, negative 3. Right? That's what I got, no. So let me see if I can do this here. So like that. And like that. Good. That's much better. So now, what's the new domain? Negative 2 to 2, and the new range is negative 3 to 3. Good. It's nice. Little bow tie there. The most unfairly difficult, one of the most unfairly difficult questions I ever gave a class was on a test where I had them 21 and 22.